All right, welcome back, everybody. 4.2 Properties of Exponents. Now we have one learning goal to evaluate expressions using property of exponents, you guessed it. And we're going to specifically focus on these three: product of powers, quotient of powers, and power of a power. And we're just going to dive through each of these, okay? So product of powers brings up an interesting situation, right? We have 2 to the power of 2 times 2 to the power of 3. Now, I know that you could do this. I know you could do 2 to the power of 2 is 4, right? I know you could do 2 to the power of 3 is, I could do this, right? 8, right? And then we could do 4 times 8, which would be 36. Lied to you. 32. Wow. Okay. Now, we know we could do this kind of stuff. But, if you think about multiplication, it's a way to simplify addition, right? If you think about exponents, it's a way to simplify multiplication. So we have ways to work with these without actually having to solve them out. Because if this was x, like you see over here, we cannot do what we did on the left because we don't actually know what x is equal to. But we want to be able to get those together because we can't solve for x if there's multiple x's in a problem. Okay? So okay. Sorry, I know I'm stalling before I show you this property because I want you to think about why it exists. We know 2 to the power 2 means this, 2 times 2. We know 2 to the power of 3 means 2 times 2 times 2. And we're multiplying in between there, right? Well, if your power is just telling you how many times you're multiplying, then aren't you multiplying 2 5 times now? Right? So can't we just say that 2 to the power of 2 times 2 to the power of 3 is 2 to the power of 5? Isn't that possible, right? And the way that we really look at this, which I'm going to do up here, and let's do this in purple, is we sit here, we say 2 to the power of 2 times 2 to the power of 3 is the same thing as 2 to the power of 2 plus 3, or just 2 to the power of 5, okay? Which we know is 32, but I'm not really so focused on that simplifying now, okay? So let's recap here. I know there was much more talking about this than I anticipated, but it's a good talk, okay? If you have the same base, so your base number, and you're multiplying, you can just add the exponents, okay? Crucial that they're the same base. If you had 2 to the power of 2 times 3 to the power of 3, you cannot simplify these this way, okay? Now look over here to the right. X to the power of 2 times x to the power of negative 5. Well, we said that we could add the exponents. So this becomes x to the power of 2 plus negative 5, right? Well, whenever we add a negative, it becomes a minus. So x to the power of 2 minus 5 ends up being x to the power of negative 3, right? Now, when we do these problems in the past and in 4.1, we always sit there and we say, don't leave a negative exponent. So we do have to take that additional step of 1 over x to the power of 3. Okay? All right. So there's a lot going on here, right? If you have the same base and you're multiplying, you can add the exponents. And whatever that looks like is whatever that looks like. If you have to do 2 plus a negative and change it to a minus, that's fine. Okay? All right, let's look at the official property. X to the power of m times x to the power of n is equal to x to the power of m plus n, okay? Same base, add the exponents, okay? Now, quick little tidbit, all right? If you have multiple variables, so if I have x to the power of 2 times y times x to the power of 3, man, let's go with something. Yeah, let's do this again. That's going to look much better in video, right? If I have x to the power of 2 times y times x to the power of 3 times y, I can still do this. I just have to focus on the variables that are the same, right? So x to the power of 2 times x to the power of 3 is x to the power of 5. Y to the power of 1 times y to the power of 1 is y to the power of 2. It's still possible with multivariables, okay? All right. Let's go to our next one, quotient of powers, right? So product obviously means multiplication. Quotient means division. And so our property is very simple here. But let's, again, we know that we can do 2 to the power of 5 is 32. And we know we can do 2 to the power of 2 is 4. And that 32 divided by 4 is 8, right? We know that we could do this a different way. But again, when you get to your variables, you no longer can do that. So let's focus on the property, all right? Okay, so let's write this out. 2 to the power 5 is the same thing as 2 times 2 times 2 times 2 times 2. And 2 to the power 2 is the same thing as 2 times 2. Well, when you look at this, a 2 over 2 equals 1, right? Another 2 over 2 equals 1. And I end up with only 3 left. And so this is the same thing as 2 to the power of 3, which is also the same thing as 2 to the power of 8, which, whoa, 2 to the power 8. Okay. See, I'm hesitant to say that you guys won't call me out, because if I say that, that means I made a mistake. All right. So let's look at the official way to do this. When you have the same base and you are dividing, you can subtract the exponents, because as you see here, that's what ends up happening. We had 2 on the bottom, so it ended up taking away 2 on the top. That's the same thing if I did 5 minus 2 to be 3. So we can write this as 2 to the power 5 over 2 to the power 2 is equal to 2 to the power 5 minus 2, or just 2 to the power 3, or just 2 to the power, 2 to the power of 8. Okay? All right. Let's do it with the variables. X to the power 5 over x to the power of negative 2. Now, I hope you see me using the negatives a lot here. I want to make sure I'm doing examples with those. But the way we apply the property doesn't change. It just might flip an addition or a subtraction. Okay? So this becomes x to the power of 5 minus negative 2, which a minus becomes a plus. And so that becomes x to the power of 5 plus 2, or x to the power of 7. Now notice that. That's really interesting here, right? We had a 5 on top, and this is supposed to, I know that 2 looks way too big. It's supposed to be x to the power of negative 2, okay? And it ended up increasing the values that we had on top. This is super interesting when you prove that this works, right? When you sit here and let's say I did this a different way, right? I had x to the power of 5 over, well, we have a negative in the bottom, so, I have to still put it underneath 1. So 1 over x to the power of positive 2 and get rid of it. Remember, this is the long way of proving things, okay? Now, this also reads as x to the power of 5 divided by 1 over x to the power of 2. And if you remember your keep, change, flip, that changes into x to the power of 5 times x2 over 1, x to the power of 2 over 1, or just, look at this, a product of powers. How you can think about this is many, many different ways, okay? For starters, you could just focus on the property and move on with your life, right? You can sit there and go, whenever I have the same base, I can just subtract these, the subtraction flipped to a plus and ended up being a 7, everything's okay. Another way you can think of it is that when you have a negative exponent in the numerator, it goes to the denominator. When you have a negative exponent in the denominator, it goes up to the top, right? And becomes a product of powers. Now, we're doing a lot of stuff here. Right? I always like to try and prove that things work. I feel like it helps students kind of get grounded in the concept that they are learning. All right. So you see that I'm doing long forms here to prove that it works. And what happens is enough mathematicians do the long form and kind of go, wait a minute, I can shorten this because I know that it works out like that. Okay. And so this is our short method, the property. So let's look at the official property. Right? X to the power of m divided by x to the power of n is equal to x to the power of m minus n. Same base, subtract the exponents. Okay. Now again, this works the same exact way with multi-variables. Let's just do it that way. Okay. So x to the power 2 over x. So that would just be x to the power of 2 minus 1, or just x on top. And then y over y, that's 1 over 1. Right, y to the power 1 over y to the power 1. 1 minus 1 is 0, so y disappears. And I'm just left with that. Okay? All right. Next property, power of a power. Okay? Now, power of a power is an interesting property. Okay? And what happens with power of a power, sorry, I lost my train of thought there. Okay, let's do this long form first, right? when you had x, let's do 2. When you had 2 to the power of 2, we knew that that was the same thing as 2 times 2. Well, when you have 2 to the power of 3 to the power of 2, that's the same thing as saying 2 to the power of 3 times 2 to the power of 3, right? This whole piece becomes a base number also to the power of 2, okay? And so we would multiply it out twice. And if you look at it this way, you can think of it as a product of powers, right? 2 to the power of 3 times 2 to the power of 3 is 2 to the power of 6 because we can add the exponents. But look at that relationship here. Isn't 3 times 2 6? Can't we simplify that if we already know? And the answer is that we can. When you take a power, hence the name, power of power, take a power to another power, we can multiply those exponents. So 2 to the power of 3 to the power of 2 can be written as 2 to the power of 3 times 2, or 2 to the power of 6, which we also know is 64. Okay? Now again, with our variable here, power of a power. You see that? Multiply the exponents. This becomes x to the power of 3 times 2, or just x to the power of 6. Okay? Now, again, that power can be distributed. If I had like an x to the power of 3 over like a y to the power of 2, and all of that was to the power of 2, you would multiply it with both of those, okay? To the top and to the bottom separately, right? Now, let's look at our property. X to the power of m to the power of n is equal to is equal to x to the power of m times n, okay? And it also, again, works for multi-variables. If you have this situation, x to the power of 2 times 2 and y to the power of 3 times 2, and you get x to the power of 4 times y to the power of 6. Now, here's what I always see. After I teach the power of a power part, I see students going back to product of powers, and they start multiplying here. You have to remember that when you multiply with the bases, you only add the exponents. Okay, so don't lose track of that. Okay. All right, now we're going to rip through some problems here. On each page, it's going to be an I do and then a you do, and there are going to be many different types of problems. Okay. Now, sometimes the problem that I'm going to ask of you is just a little bit more than the problem that I did. Okay. And the reason for this is sometimes we have to show you the tools and ask you to apply them to something that we have not shown you, so that it's not just doing what I did. If you think about learning, if you think about critical thinking, and it's doing stuff that people haven't always shown you, right? So I want to try and get a little bit, more into that, all right? So 3 to the power of 4 over 3 times 3 to the power of 5 over 3. These are rational exponents. We're kind of bringing them back. And product of powers becomes super useful with rational exponents. So watch this. Same base. It's always your first step in identifying. Same base. Add the exponents. This is 3 to the power of 4 over 3 plus 5 over 3, which we know by adding fractions, they have the same denominator. That becomes 3 to the power of 9 over 3, which we know 9 divided by 3 is also just 3, so that's 3 to the power of 3, which equals 27. Look at the difference in this, right? Product of powers helped us not even deal with the rational exponent because we were able to simplify it away. Instead, if I wanted to do this before, I might have had to put these both into, a radical form, which could have been a lot of work, or, use a calculator or some other things, right? But instead, product of powers took a complicated problem and showed us that this entire piece here is really just a 27, okay? And I don't know about you, I'd rather write it as a 27, okay? All right, now, number eight. The next problem on the right, I'm gonna let you guys try it. There is a negative in there, don't forget that, and then I'll go over it. So give it a try. All right, so hopefully you gave that a try, you used your product of powers, you have the same base, so we add the exponents, so this is 8 to the power of negative 5 over 3 plus 6 over 3, okay? Now, if you look here, negative 5 plus 6 gives you just 1, which means you do have 8 to the power of 1/3, okay? Now, our negative exponent was handled on its own. Now we didn't even have to deal with it, right? Now, here's the interesting part about this, okay? After this point, this one could be simplified further, okay? And if you can simplify further, you want to. Sorry. Now, if you get to this point, you're pretty good at this point at understanding the new property, all right? But we do know from the last lesson that this is the same thing as the third root of 8 to the power of 1, and the third root of 8 being 2, and then 2 to the power of 1 is just 2, okay? And again, this is why, why do I have to simplify? This is why. Why write this when you can write this, okay? So if you can't simplify, do so. All right. Okay, we got another 2. I'm going to do the left. You're going to do the right. And I know the right looks a little bit more difficult, okay? So this is our, wow, we're kind of jumping right into power of a power. I do quotient? Yeah, I do quotient on the next page. Mess that order up a little bit, but that's fine. Okay. So 7 to the power of 3 to the power of 2/3, okay? Again, these look super complicated, but trust your properties. Power of a power, that is 7 to the power of 3 times 2/3, okay? Now, I'm going to write this 3 times 2/3 to the right because we're going to do this 2 different ways, okay? The first way, it's the OG way. You put a 1 under it. 3 times 2 is 6. 1 times 3 is 3. 6 divided by 3 is 2. So we really have 7 to the power of 2, which is much easier of a number, right? But you also have to remember that you could do this as 3 times 2/3, and you can cross-cancel those 3, and you're just left with 2. Use either method that you prefer. Okay, now jumping back to the 7 to the power of 2, we can simplify that to be 49. Now look at this. This property took something that was complex and allowed us to get something that makes meaning to us. 7 to the power of 3 to the power of 2/3 is not something that's easily rationalizable. That's not a word. It's hard to rationalize a number like this, right? If I told you, hey, that length is 7 to the power of 3 to the power of 2/3, you'd be like, I can't visualize what that looks like, right? But if I told you the length is 49, you can visualize that, okay? All right, here's the one on the right. Give it a try, and then I'll go over it. Okay, 64 to the power of 3/2 times -1/3, all right? Trust your properties. Power of a power. That means I have 64 to the power of 3/2 times -1/3, okay? All right, so we multiply those. 3 times -1 is -3. 2 times 3 is 6. -3/6 turns into a -1/2. Okay, now, unfortunately, we ended up with 64 to the power of -1/2. We do have a negative exponent. Never, ever, ever leave a negative exponent if you can't, right? We're going to simplify this. This becomes 1/64 to the power of 1/2. And remember, anything to the power of 1/2, that's just like saying the square root, right? Because if you think about it, you put 1 over the second root of 64 to the power of 1, which I'm not going to write that. Well, that's just the square root. So anytime you see 1/2, it's like taking the square root. The square root of 64 is 8. So your answer is 1/8. Again, this number up here is hard to think about. 1/8 is not. 1/8 you would see on a standard ruler, okay? All right. Next 2, and I believe these are not the last 2. Okay. That's what I meant to say. I believe they are not the last 2. Okay. I'm going to do the left. You're going to do the right. So, quotient of powers, right? We see dividing. We see the same base. We go right into our property. I'm going to take 32 to the power of 7/5 minus 9/5. Because when you have the same base and you're dividing, you subtract the powers. So you get 32 is equal to -2/5. Okay, so we're going to have to put this 1/32 to the power of 2/5, which again, I'm going to write this in radical form now. 5th root of 32 to the power of 2. Now, super important to remember your base too. Like I can look at this. 2 times 2, 2 to the power of 5 is going to give you 32, right? 2 times 2 is 4, so that's 2 2s. Another 2 is 8. Another 2 is 16. Another 2 is 32. That's 5 2s. So I don't know if that was really helpful, but Base 2 is super important. Think about that. Like really think about that. What could you possibly multiply 5 times that gives you 32? If I multiplied the 4 5 times, I get a way bigger number than 32, right? So you're going to see a lot of 2s and a lot of 3s as your answers, okay? But let me write this. Over here awkwardly. I would get 1 over 2 to the power of 2, because the fifth root of 32 is 2. I still have that power, and you get 1 over 4 as your answer. Much easier to think about than our previous problem. Okay, now, this one on the right. I'm going to do this one. I was going to have you guys do it. I'm going to do this one. Okay, yeah, I'm going to do this one, all right? So we have a combination here of some of these powers. Inside here, we have a product of powers, right? But then outside, we have a power of a power. My advice is sometimes to simplify it before doing anything else, if you can. I'm going to try and simplify what's inside the parentheses before dealing with what's outside of them, okay? I just find that it leads to more simple problems. So we have a product of powers, 5 to the power of 4/3 plus a negative 3 over 2. So that really becomes 4/3 minus 3 over 2. Notice something here. We no longer have a like denominator. So we're gonna have to deal with that. So 4 over 3, and we're gonna move this into a minus 3 over 2. Okay? I need to get the same denominator. So, there's a lot of ways to do this, but sometimes it's best to just multiply the denominators together, right? So go like this, back that way, and then you're going to multiply across and multiply across. So, yeah, that drawing looks weird. So basically, I take the left denominator, and I multiply it to the right, and I take the right denominator, and I multiply it to the left. And so you should get 8 over 6 minus 9 over 6, okay? 8 minus 9 now gives you negative 1 over 6. Okay, so I'm going to have 5 to the power of negative 1 over 6. Okay, now all of this will be taken to the outside of negative 6. Okay, now here I'm making a judgment call. I know we want to rationalize these negative exponents because they don't often make a lot of sense to us, right? So you would put that under 1 to get rid of it. But I'm looking right here and I see power of a power. I'm going to have to multiply, and it's a negative times a negative. So that's going to handle getting rid of that negative for me. So I don't need to put it under 1 first, okay? Now, any step that you should take that's valid should get you to the same answer, though, okay? It just would have been a roundabout way because you would have had to put it under the denominator, then multiply by a negative, and then put it back to the top, okay? All right. So we get 5 to the power of negative 1/6 times negative 6. Let's put that. And I mean, you could see this a lot of different ways here, right? But negative times a negative, we know we're going to get a positive. We have a 1 times 6 to be 6. We have a 6 times 1 to be 6. This is really just 5 to the power of 1, or just 5. Notice how this big piece here turned into just a 5, okay? All right, so that was a little bit longer one. Good thing I didn't ask you to do that one ahead of time, all right? All right, here's the next one, okay? Yep, they're getting more complicated, and I'm going to talk about this why. I am going to have you do the second one first. I think it'll be fun. It'll be fun. You guys will have a great time. Okay. When you get to a problem like this, you have a lot going on, right? But at the same time, it's really just a lot of quotient of powers, right? And we've shown a little bit of multivariable, okay? So here's what I advise doing. Simplify the top and simplify the bottom first, and then start looking across. I see we have a y to the power of negative 3 times 16 times y to the power of 1. So let's simplify that. And we should get 4x y to the power of 3 over, well look, y to the power of negative 3 times y to the power of 1, product of powers, negative 3 plus 1 is negative 2. So we get 16 times y to the power of negative 2, okay? Now, the way we deal with this going through now is we look at the numbers, we deal with those, we look at the similar variables, which notice how there's no similar x, so that's not going to change. And then we have our y's, we have our quotient of powers. So let's simplify. 4 over 16 is the same thing as 1 over 4. I can't go any further than that, okay? I have an x on top because it has no other x, so it just stays. And I have a y to the power of 3 divided by y to the power of negative 2. Quotient of powers. So that becomes 3 minus negative 2, or just 3 plus 2. So it becomes y to the power of 5. And this is your final answer. Okay? Now, something to kind of notice here, when you have that negative exponent on the bottom, it ends up increasing your top. Okay? All right. In fact, I just want to show you one quick thing. Okay, let me just bring us back here to 4x y to the power of 3 over 16y to the power of negative 2. Another way of thinking about this is that when you have a negative in the denominator's place, it's the same thing as bringing it to the top and making it a positive. Sorry, let me rephrase that. When you have a negative in the bottom, it's the same thing as bringing it to the top. When you have a negative in the top, it's the same thing as bringing it to the bottom. So this could also be read as 4 over 16 times x times y to the power of 3 times y to the power of 2. And if you look at the product of powers, it becomes y to the power of 5, just like we said it would. So that's another way of thinking about it. Okay, give this a go on the right. I know it looks tough. I believe in you guys. Give it a try, and then I'll go over it. Okay, so let's go over it. We got a lot here. Remember, simplify the top, simplify the bottom. I look at the top, not much going on to simplify there. It's all pretty packed, okay? I look at the bottom, I see a multiplication there. It's not the best multiplication symbol, but it is here. So I'm going to multiply this with this. And really, that's just, combining your y's, combining your x's, okay? So let's do that. All right, let me write this over here. Equals, I'm going to put the top. So we have 2 times x to the power of 1/4 times y to the power of negative. Yeah, we're going to need a smaller thread here. So 2x to the power of 1/4 times y to the power of negative 5/3. And all of that is going to be over, well, let's see, I have a y times a y to the power of 1/3. Okay, well, let's write that to the side. Y times y to the power of 1/3. Well, we add the exponents, right? But, 3/3 is the same thing as 1, right? So I kind of very quickly going, let me make these have similar denominators, right? Whenever I have 1, I always just pick the denominator and then put it over itself, because that's the same thing as 1. So if I see a 3 over here, 3/3. If this was an 8, I'd put 8/8, because it's all 1, all right? And so you add those together, and you get 4/3. So now on the bottom, I have a y to the power of 4/3. Okay, I'm going to bring my 8 down because there's no other number, and then I'm going to deal with my x's. I have x to the power of negative 3/4 times x to the power of 2/4. Now 2/4 looks like it could be simplified to 1/2, and it can be, but I have to add it with negative 3/4, and so, I might as well leave it as 4 because they're like denominators. So negative 3 plus 2, and I should get x to the power of negative 1/4. Okay? All right, so x to the power of negative 1/4. All right. Now we start going across here. I got 2/8. I got x to the power of 1/4 divided by x to the power of negative 1/4. And then I have y to the power of negative 5/3 divided by y to the power of y something. Divided by something. Okay? 2/8 simplifies to 1/4. 2 goes into 2 one time. 2 goes into 8 4 times. Okay? Now your x to the power of 1/4 divided by your x to the power of negative 1/4 turns into x to the power of 1/4 minus a negative 1/4, right? Because we're using quotient of powers here. So that's the same thing as x to the power of 1/4 plus 1/4, or x to the power of 2/4, or just x to the power of 1/2. Okay, so let's leave that. X to the power of 1/2. Notice how it stays on the top after I do those quotient of powers, okay? All right, then I have my y to the power of negative 5/3 divided by y to the power of 4/3. So same thing, y to the power of negative 5/3 minus 4/3. And so that becomes y to the power of negative 9/3. Okay. Whoa, I don't know why I said equal. Comes y to the power of negative 9/3, which simplifies to y to the power of negative 3. Okay. Now, This still goes on the top once we do this. Y to the power of -3. That does not stay on the bottom, okay? But we know when we have a negative exponent, we have to get rid of it. And when we have a negative exponent on the top, it goes to the bottom. So we get equals 1 over 4. And then we have x to the power of 1/2 over y to the power of 3. Boy, I hope I did everything right in this problem. Okay, tremendous amount of work, all right? If you got stuck, it's kind of obvious as to why, right? Now, we're going to leave this rational exponent. We're not going to change that here because written as a rational or written in radical form really doesn't change anything because it's an x and we can't do anything with it, right? If it was a number that benefited from putting it into a radical form, then you should do so, okay? But yeah, that would be your answer. You might be going like, okay, you had me in class with, finance being important, right? But like this nonsense, that whole thing, that's going to be used in finance. And the answer to that is, there are situations where you'll have a ton of rational exponents, okay? But most of the time it comes in simplifying long problems that we run into these cases, okay? But you will see on math placement tests, you will see these problems because they can test all the exponential properties in one problem. And when you have a placement test like that, and you have to really carefully choose how many questions are going to be there, and you have to test as many subjects and concepts as possible, they're going to opt to put problems in that test more stuff, okay? So they can put less problems. So you will see this. I mean, think about it. You did quotient of powers, you did product of powers, you dealt with negative exponents. That's 3 properties alone. So you're going to see stuff like that on math placement tests for sure. Now, that is the end here. This is definitely a long video, all right? Hopefully you understood this. Hopefully there were no errors, but at this point I'm not counting anything out, all right? So I'll see you guys next time. Hope you enjoyed the video.